Okay, so just to recap, in our last video we learned that if we had something of the form exactly x to the n, we could take the derivative and we would get n times x to the n minus 1. Now, that didn't allow us to take the derivative of something like this, because this isn't exactly of the form x to the n. So how do we take the derivative of more complicated expressions like this? Well, we actually have this rule above, that if I take the derivative of some constant times a function that I already know how to take the derivative of, I get just that same constant times that derivative that I knew how to take, right? So below, what this means is I can kind of set this off in square brackets and say, well, this whole thing down here is just of the form some constant times something I know how to take the derivative of. So if I want to take the derivative of this, all I need to do is do that same constant, that same 3, right here, times the derivative of what was inside those brackets, right? And this only works for constants times a function I exactly know how to take the derivative of, right? So inside these brackets, I'll get 2 times x to the 2 minus 1, right? Which is equal to 3, and then in the brackets I have 2 times x. Now I want to simplify this, because these brackets are really just parentheses, and this will be 6x, right? So similarly, if I had this one, so how could I interpret this one in this way? Well, 3 over x squared, I can rewrite this. I still have to put it into this form, right? C times something I know how to take the derivative of. And the way I'm going to do that, I'll write it as 3 times 1 over x squared, which gets me almost all the way there. This thing here is almost like this, and I want to write that actually, to get it all the way, is I'll write it 3 times x to the negative 2, right? So again, I have c, my 3, times a function I know how to take the derivative of, right? So I'll take d over dx, and I will get 3 times the derivative of that function, right? So negative 2x to the negative 2 minus 1, which is equal to 3 times negative 2x to the negative 3. And again, these are just normal parentheses, so I'll get negative 6x to the negative 3. So again, just using this rule, all right? So a constant times a function that I already know how to take the derivative of, which so far is only this, right? Let's look at another rule like this. All right, and so what this is saying, what this rule down here is saying, is that if I have the sum of two functions I know how to take the derivative of, I just get the sum of the derivatives. All right, so look at this thing below. This is almost like that, right? So let's actually rewrite this a little bit. We'll rewrite this as x to the negative 1 plus x to the 3/4. I haven't taken a derivative yet, right? But now I can. It tells me to take the derivative, so I'm going to take the derivative. I can, because I know how to, I'm going to look at this as f of x, and I know how to take the derivative of this. I'm going to look at this as g of x. I know how to take the derivative of this, right? Just using that power rule, x to the n. If I take the derivative, I get n x to the n minus 1. And so I can take the derivative of the sum by just looking at the sum of the derivatives, right? So I'll get negative x, negative 1 times x to the negative 1 minus 1, not 2. It's a little bit early in the morning. And here, I will again bring down my power. So 3/4 x to the 3/4 minus 1. So in the end, I'll get negative 1 x to the negative 2 plus 3/4 x to the negative 1/4. Right? I can do the same thing with differences of functions, right? So if I have a function I know how to take the derivative of, minus another function I know how to take the derivative of, I just have the derivative of that first function minus the derivative of the second. So we have something here that's similar, right? So I know how to take the derivative of this first thing. Now the second thing I'm going to rewrite. Remember, something on the bottom is really just a negative power. I have not taken a derivative yet, but now I can, since I know how to take the derivative of this and the derivative of this, and they're subtracted. I'm going to use this rule above, right? So d over dx, and I'll get 1, so this is really x to the first power. Remember, that's why I know how to take the derivative of it. X1 times x to the 1 minus 1 is equal to, or minus, not equal to, boy, early morning's getting to me. So minus negative 3/4, I'm bringing down my power, x to the negative 3/4 minus 1. So let's simplify this. Remember, this is 1 x to the 0, and then minus a negative is really plus. So plus 3/4 x, and I'm doing negative 3/4 minus 1, which is going to be negative 7/4. Now remember, x to the 0 is always 1, so you just end up with 1 times 1, which is 1, plus 3/4 x to the negative 7/4. All right, so that's your answer there. So just to recap, if we have a constant times something we know how to take the derivative of, we can just do the constant times the derivative of that function, kind of an intuitive rule. And the same thing with sums of functions we already know how to take the derivative of, and differences.